Einen wunderschönen guten Tag aus Berlin. Hi, my name is Matthias Rillig, and today I'll talk to you about multiple factors and their influences on soil. So why should we care about the effects of multiple factors on soils, and why is this so difficult to do? So first of all, why should we care? Well, it is reality. This is what in fact is going on out there. This is how we as humans are affecting our environments, terrestrial and aquatic, and especially the soil, because by virtue of gravity, in the end, of course, everything ends up in soil. If you think just of global change alone, global change consists of many factors, including climate change, invasive species, and all kinds of different aspects of pollution. And when we started thinking about this topic first, we looked at what had actually been done in terms of experiments. And we were actually quite astounded about how extremely little there was actually done in terms of experiments on multiple factors for soil. So in 2019, we did a literature survey where we specifically searched for just data from experiments. So not observational studies, just experiments. And we looked for global change factors defined very broadly and how they might affect soil. And so what is your guess? What percentage of studies would address more than two factors? So I guess we started out thinking that relatively few studies would have looked at more than two factors, but actually we found that less than 2% of all studies had actually looked at more than two factors at a time, say like drought and warming. And so in essence, we are almost completely blind in terms of at least experimental data as far as these higher order interactions are concerned, which, as we just discussed, are actually reality. This is what happens on. These factors are really what happens out there. So why is there so little information from experiments? I think that there are mainly three reasons. The first one is a technical reason. So this is called the combinatorial explosion problem. And it's actually pretty easy to explain. So imagine you had 10 factors that you would like to study. And so, if you just had two factors and two levels of each of these factors, you would have two levels of this factor combined with two levels of the other factor. You would have four different combinations of these two factors. So just imagine if you added just one other factor, you would have 2 by 2 by 2, so you would have 8 combinations. If you added another factor, it would always double. So it would be 16, be 32, 64, 128, 256, 512, and then for 10 factors, you would arrive at 1,024 different combinations. So you see, it just explodes. And of course, nobody can do an experiment in ecology, at least, with 1,024 different factor combinations. That's just simply impossible, because you also have to have replicates, and somebody has to analyze all this. So it's completely out of the question to do experiments like that. So the tool with which we have addressed factor interactions is the factorial experiment, which I've just explained to you. It's like combining all levels of one factor with all levels of the other factor. This is the most commonly used experimental design in our lab and many others, and fundamentally this design does not work when you want to look at many factors at the same time. This design fails when you want to look at many factors. So that is one reason, this combinatorial explosion problem, when you look at many factors and you want to do a completely factorial experiment. It just simply does not work. The second design is more like a sociological barrier in essence, and that is that if you want to study certain factors, you need to you need to substantially gear up. So if you wanted to study warming, you would have to have the warming elements, for example, heating cables or infrared heaters. And that's quite an investment to tool up, basically, to study this factor, or other factors that are a lot of work to set up and require specific investments, exposure systems, for example, to atmospheric CO2, or in different ways. If you wanted to study invasive species, you would have to tool up for such a biogeographical study, in essence. And so many of these factors, some of them are easier than others, but many of these factors require you to a certain degree to specialize. And this is what really has most likely happened. There's labs that specialize in invasive species. There are labs that specialize in drought. There are labs that specialize in microplastic effects and whatever have you. And so this research compartmentalization leads to people studying their particular factors and not looking broadly at very many other factors. So compartmentalization is the second reason why we know so little from experiments about the action of multiple factors. And then a third reason, maybe more like a psychological reason perhaps, it's there is an implicit assumption out there that studying just the main factors is enough. There is often the big four that are named: drought, warming, nitrogen deposition. It may be true that some of those factors, in combination, capture quite a bit of what global change is all about and what human influence on soil is all about, but it's certainly not everything. So focusing on just a few main factors, we may be missing out actually very many important interactions that go beyond just these couple of factors. And so what's the way forward, really? Well, what we need are some new experimental designs. In my lab, we tried a new experimental design that is basically consists of sampling factors randomly from a pool of factors and just making a gradient this way of increasing numbers of factors. Of course, it has advantages because we could have a glimpse at what might actually happen with some of those higher order interactions, which led to some completely surprising results. But of course, it comes at the cost of not being able to say which particular combinations of factors actually caused any particular effect. But more importantly, I think we need to move the conversation to these multiple factors and multiple impacts rather than just studying just a few factors in isolation, or also just basically pitting one factor against another in terms of its importance. I think it misses the point. I think the most important point is really to try to orchestrate a concerted effort from the scientific community to really get at this problem. And it's definitely not easy, but I think getting in this direction would be one decisive step forward to more adequately studying global change, or more generally our impact as humans on soils. Oh boy, that video was something, huh? So if you liked it, don't forget to hit like and remember to subscribe to this channel. See ya.